are working in our worksheet packet. We're going to be on the back page, and we're going to do this sample number 9 together with pictures. All right, so the first thing that we need to do, so we're going to determine the specific heat of brass. They give us a bunch of numbers, but I'm going to diagram them so that it makes sense. First thing we need to do is we need to take our piece of brass. This is my piece of brass. Oh, yes. Oh, that's one of those little weights that I was just holding up on the fishing line. Doesn't it look the same? That's the little thing that you tie the fishing line around so that you can hang it. Okay. And in number 9, it says that I have 325 grams of brass. What I'm going to do with my brass is I'm going to heat it up. Ooh, are those some nice flames? Now, we're not heating ours up that way in the lab. We are going to put it in boiling water. So I'm going to heat to, what does the question say I heated it to? 100 degrees, just like we're going to do in our lab by putting it into boiling water. When water starts boiling at 100 degrees Celsius, the temperature doesn't go up anymore. It stays constant. So that'll make it consistent. Then, second step, I'm going to need a known amount of water. So on number 9, I've got a cup with 162 grams of water. This is like my calorimeter. It's got water in it. I've got 162 grams of water, H2O. The water is at T initial 24.3 degrees Celsius. I also know the specific heat of water, but I'll get to that later. And then, so I measured the mass, I measured the temperature, and then I'm going to combine them. Step 3. So I'm going to draw my nice cup of water. It looks like my cup got bigger, but it didn't. And I'm going to put my piece of metal in there. What's going to happen to the temperature of my metal? It was at 100 degrees, and now I'm putting it into 24 degree water. Its temperature is going to go down. What's going to happen to the temperature of the water? It's going to go up. Why? Because we got some heat moving here. 2 different temperature differences, we're going to have heat moving. And heat always moves from warmer to cooler objects. It's just natural. It's entropy. Just the natural order of nature. It's going to move. The heat moves. That right there, that's heat. Heat is when energy moves due to temperature differences. So that's my heat. Heat is energy that moves due to temperature differences. If these two were at the same exact temperature, then nothing would happen. You would just be putting it in there. There wouldn't be a big heat movement. Heat is energy that moves due to temperature differences. And then it tells us what the final temperature is in number 9. The final temperature comes out to be 37.4. That's for both of them. The final temperature is always the same because heat is going to continue to move until their temperatures balance out. So final temperature for both of them, T final is 37.4 degrees. I'm just getting these off of that problem. And that is for both of them. So I'm just going to write it twice. So whatever heat the water gains, it's equal to the heat that the metal lost. It's the only place that we have heat. I'm going to go with blue. So heat that the metal loses, oops, it's not metals, it's metal, equals the heat that water gains. So Q of the metal is going to go into Q of the water. Their heats are equal, but there's one little trick to this. Remember that problem we did at the end of the class yesterday? We ended up getting a negative for our heat. So whenever something is losing heat, it's not losing, it's just giving it to somebody else. It's negative. Heat's being released. So if I calculate how much heat the metal loses, it's going to be negative. But if I take that number and I try to plug it in equal to this, when energy is gained, that's always positive. So a negative and a positive are not going to be equal. So what I have to do is I have to add, I need like a really bright color. I have to add a negative over here in order to make the math work out. That's why they're called Q equals negative Q problems. And you know what? Even though I have to do this on every single problem, sometimes I take a quiz and I decide not to do it. So I'll write myself a little note here. I have to add negative to do the calculations. But if you show your work, these problems, I have to add the negative to do these. And I always circle my negatives so I don't lose them. All right, I'm going to need another piece of paper because I wrote really big today. We're going to do the math. See this Q equals Q? We're going to use all these problems. This is actually number 9. You could try to fit it where number 9 is, but I just don't know how you would do that. I really want to use a pen this time so it shows up. All right, so I've got the negative Q of my metal, which we had brass for this one, is going to equal positive Q of my water. What's Q equal to? MC delta T. So I've got negative mass of my brass, C of my brass, T final of my brass, minus T initial of my brass, equals, I need the mass of my water, I'm going to do H2O, the specific heat of my water, H2O, T final of my water, H2O, T initial of my water. There we go, just a little teeny math equation. I would at least write out like MC delta T and label one side brass and label one side water. Like maybe write the word water here. Water, brass. And now we just go find our numbers and plug and chug. That negative is just, I'm putting that out there. So bring that down. What's the mass of my brass? That one was 325. Specific heat of my brass? Oh, by the way, that's what we're doing. We're determining the specific heat of a metal. I should have highlighted that first. I generally try to pick out, what I'm looking for. That way I know what numbers I have to have. So that's my variable, C of the brass. T final of the brass, 37.4. That's its final temperature. Initial temperature of the brass, it was at 100. Mass of my water, 162 grams. Specific heat of water. Now that one I don't have in here. Remember where to find it? It is on the data table. 4.184. That's going to be your new best friend. You're going to use that number so much. Final temperature of the water, 37.4. Always the same. Your final temperatures have to be the same in order for this to work out. Minus initial temperature of the water, 24.3. All right, there we go. Just a little math equation for us to solve. And this is the easy version. Solving for final temperature, we have to distribute. This one, you just can multiply and divide. It's great. So which side? I'm going to go ahead and start on the right side since I don't have a variable there, and I'm going to combine all those numbers. So these problems are 5 to 6 points. Definitely show me as much as you can. Like if you forgot the negative, which is like essential to this problem, still going to give you like 5 out of 6 points. Like you'll still get the points for everything else. The temperature changes, those are always a point on each side for making sure you had the right ones. So over here, parentheses, 37.4 minus the 24.3. So that's a 13.1. So I can multiply those three numbers times 4.184 times 162. So that's 8879 point blah, blah, blah. Over on the left side, the 37.4 minus the 100, you get negative 62.6. Negative times a negative equals a positive. The whole point of that is just to cancel out. So that number times the 325, and I get 20345 over here. Negative times a negative cancels out. So that's positive times my C. So then 8879.2848 divide the right way. You're getting that guy by itself, divided by 20345. C is 0.436 joules per gram degrees Celsius. Oh, look, one problem we did today. Where did I get the units? I mean, technically, if you canceled everything out in here, but I just cheated and I knew that those were the units for specific heat. And specific heat and mass should never be negative, never. And so if you get a negative answer there, you did something wrong. Now, temperatures, those are harder, and they can sometimes be negative. So then back here on my picture, I was going to write maybe a few things, those things I just said. C and M are never negative. It's hard with temperatures because you can have negative Celsius. You really shouldn't, though. You shouldn't get negatives because if we're always putting it in water, if you had a negative temperature, that means the water would be frozen, and that's not likely in these problems. We're not going to try to put the metal in a piece of ice. So specific heat and mass are never negative. Also, the negative is supposed to go on the side with the higher temperature. It doesn't matter. If you put that negative on one of the sides, you'll get the math right. So just add the negative. Either side, but put it out front. Technically, it's supposed to be at the one with the T initial is higher. That's the side it's supposed to go on because that's the side you'll get the negative on to cancel out. All right, you are going to try the rest of the ones on that page in your packet. A lot of places you can make math errors, so we really need to practice these. So we just did number 9. So you're going to do 7 and 8, and 10 is tricky. So most people, if you're really good at math, you'll get to this. So let's see if you can do that one on your own. This one, you're solving for final temperature, so you're going to have to distribute. It's not new math. You should be able to do it. But it's enough, right? I just did enough problem for today, so it's time for you to try. And then tomorrow I won't see the majority of you. Thursday when you come in, we're going to actually set this lab up and do it. Friday we'll do the calculations to it, and we will finish the Mastering Chemistry. So that's the same Mastering Chem that we've been working on all week that's on this Friday. And then Monday, because it happens to be a Monday, we're going to take a quiz over this, review, test Tuesday.